Hi everyone, and welcome to this overview of some field tests of SICK Thermal Pro with a non-stock lens. So this is kind of a companion video to the previous one that explained what kind of lens I used, etc. So before we go into the actual field tests, a couple of words about what the setup actually is. So here on the first image you can see the actual phone dongle with the lens assembly installed onto it, and on this image you can see what the assembly basically is. So it's a couple of pieces. One of them is the one that houses the lens itself, and it's a single lens setup, and the other one is just essentially the housing for that lens that allows it to be screwed in and out to just focal distance. And then, as you can see on this slide, I've attached a rubber band to the back of the assembly, so it can be attached to the SICK thermal lens, or rather SICK thermal dongle itself, instead of the stock lens. The stock lens has been removed before I attached this one. And yeah, basically we're back to the overview slide that just shows you how the whole thing looks when it's attached. And the first field test will be of the moon. Because it's an object you can record pretty much anywhere on Earth, and it will be more or less the same size no matter where you record it, and also being some 400,000 kilometers away, it does give you a pretty good idea of how the whole system functions at respectable distances, provided the object is large enough, of course. So the first frame here shows just the moon in normal camera. The shot is oversaturated and overexposed a bit because, well, you pretty much just want to see the shape. It doesn't really matter if the colors are true or not in this shot. And you can see that it's not exactly a crescent, it's like half of the moon is visible in visible light. And now we go to SICK thermal with the stock lens, and as you can see, the moon itself is visible. It's definitely there, that dark spot over the top of the house, but you can't really tell the shape exactly. It's more of a couple of pixels large object, so not exactly 1 pixel, but well, you can't really tell the shape. And now when we exchange the lens for the non-stock one, that gives much better zoom, essentially. Here you can not only see the actual shape of the moon, so it's not just a dot, but it's half of a circle, but you can actually see a thermal gradient. So the part on the left that's being heated by the sun more directly is actually hotter than the one in the middle that is hit by the sun much more tangentially, so it's not as heated as the left part. And for the second field test, we're going to look at a duck in a local pond. As always, there is the visible light image first. You can see there is a raft in the center, and the duck is standing on that raft, and then there is, the pond around it, some algae and whatnot on the surface on the water, and not much else really. So as we go to the stock lens of SICK Thermal Pro, you can see that both the duck and the raft have a pretty good thermal contrast, because the raft has been heated up by the sun during the day, and the duck is warm-blooded, so it's just warmer than the environment pretty much by default in most situations. We are using a different color map here, well, just for the sake of seeing how it looks in a somewhat different color map, I guess. And now we are switching to the non-stock lens that gives better zoom. While I was switching lenses, a couple of ducklings showed up near the lone duck on the raft, and you can see them in the background swimming around. So as you can see, this gives you better zoom, obviously, but you don't really lose that much in terms of thermal contrast, to be fair, which is quite promising.